Now the test-driven development process. So let's break down the test-driven development or TDD process into 3 stages: red, green and refactor. So in the red phase, we start by writing a failing test. And this test defines the behavior we want to implement. And in the green phase, we write the minimal code. And in this phase, we create this green phase to make the test pass. And refactor phase, in the refactor phase, we refactor the code after making the test pass to improve the code quality while maintaining the desired behavior. Now we'll go for a practical example. So let's put TDD into practice by writing a simple unit test for calculating the factorial of n numbers. And we shall use XUnit testing framework and Fluent Assertions library to write our tests. So first of all, here is the example of the failing test. Now we'll see it in action soon on Visual Studio. Now this test, the fact is the attribute for writing an XUnit test. So by writing this fact attribute, it understands that it is a XUnit framework we are using. So void factorial should calculate the factorial. So we are initializing a number, an integer number, and we are calling an object of calculator class. We are creating object calculator of the class calculator. Now here we will soon see that this calculator class is just a shell class at the moment, and we are calling the calculator class's factorial method and passing the number. Okay, and the result should be 120. Expected factorial of 5, 1 into 2 into 3 into 4 into 5 is 120. So let's see in action. So on my Visual Studio, I have created a TDD demo solution, okay, in which there is just one project, test project, and if you click on this test project, it will give you project, package reference. It includes the NuGet package Fluent Assertions, and it also includes XUnit. So back to our test-driven development.cs class. So this is the same test that we just discussed in the slide, and let's see this in action. So if I click on tools and rather test, run all tests, it will build first, and I expect this to fail. Okay, this is a failing test. All right, because this has got the calculator class is there, but I don't have any logic. I have commented the logic, which will soon uncomment, and it is just returning 1, but the expected value should be 120. So you can see this is a failed test, expected result to be 120, but found 1. Okay, so if I just make it a little big, here, this is this line. All right, now let's make the test. Next is the green phase. So my code is already there. Let's uncomment this. So uncomment this and let's comment this, because it should return the proper result from this factorial method. So return, it should be return result. Right, and then let's run this test again. So I will run again. Let's see the result this time. See, this time there is a green tick, so this test has passed. Okay, so this is a pass test now. Okay, if you click here, 1 passed. Right, so let's enter the refactor phase. Now before entering the refactor, let's see what was the green phase, writing the minimum code. So this factorial method is actually taking an argument of n. Okay, and if n equals 0, it returns 1. Factorial of 0 is 1, and then it is returning this result here. So int result equals 1. But for this is the actual logic. For int I equals 1, I less than equals 5 in this case, because we are entering 5, I plus plus. So result is multiplied by I. Result into equals I. Result is multiplied by, result is replaced by rather result into I. So it is 1 into 2 into 3 into 4 into 5. Alright, and then it returns the result. So that's how it calculates the factorial. Alright, so let's, before entering the refactor phase, let's do what is the refactor phase we are going to write. So in this refactor phase, we have added another method. So it is a sum, it returns the sum of two numbers, which is an integer. So that is the refactor phase. So flipping over to our Visual Studio, let's include this method. This is the sum method. So I will enter this sum method over here. So here in the refactor phase, as I just showed you in the slide, we'll add this sum method. Okay, and how to test whether this refactoring of the code in the calculator class by adding this sum method has not broken anything. So we'll write another test. So let's see that in code in the slideshow. So the next one is a new test we are going to write to check to see refactoring doesn't break the code base. So public void sum should calculate the sum. It's very easy. So you're creating an instance of calculator class and you're calling the sum method and passing two numbers, 3 and 4. The result should be 7. Okay, that's what we are going to add in the Visual Studio and see the result of a passing test. So now to see this additional test in action, first we have actually written the fact attribute, which should be there, and let's flip over to Visual Studio once more, and I have written this test already over there. Now you can see there are two tests actually, one pass test, the previous one, factorial one, and another not run test. So let's run all the tests again, rather run all tests in view, either from here or from here, run all tests. Okay, so run all tests. Now 2 passed. So both the tests have passed. So our refactoring is successful. So we have seen red, green and refactor phase without breaking the code after the refactoring. So what is the next slide? Let's flip over to the slideshow once again and see the iterative process. So TDD, as we have seen, is an iterative process and not a one-time activity. We cycle through these iterative phases for each new feature, and every iteration solidifies our code base and keeps the test suite strong. This practice helps us maintain a safety net of tests as we continue development. And let's see the benefits and conclusion. So just to recap or to sum up, it has got fewer bugs, an early bug detection. Because of early bug detection, there are fewer bugs we have to encounter, and enhanced code quality and design, and it has got a better test coverage and maintainability and improved development efficiency, and that's all.